Hi Math 3 students, so today we're going to go over the Ready, Set, Go from 6.5. So for the Ready, it says we're going to be comparing radius and arc length. All right, so stagecoaches and wagons in the 1800s had wheels that were smaller in the front than in the back. The front wheels had 12 spokes. The top of the front wheel measured 44 inches from the ground. The rear wheels had 16 spokes. The top of the rear wheel measures 59 inches from the ground. For these problems, disregard the hub at the center of the wheel. Assume that the spokes meet at the center at a point. All right, so first I want us to find the circumference and area of each wheel. So first, let's go ahead. I'm going to do the front wheel. All right, so the front wheel we know has 12 spokes, and it tells us that it measures 44 inches from the ground. So if this is our wheel, and the top front of the top of the front wheel measures 44 inches from the ground, that means from here to here is 44 inches, right? So that means that our diameter is 44 inches, which means our radius is 22 inches, right? Because the radius is half of the diameter. All right, now to find area, all right, so area of a circle equals pi times radius squared. So for the area of this guy, we're going to do 22 squared times pi. All right, now 22 squared gives me 484. So I get 44 pi, and then this is going to be inches squared because it's area. All right, so then to find the circumference, there's really two equations for circumference. You can either do diameter pi, or you could do 2 pi times the radius, which makes sense because 2 times the radius gives you the diameter. So they're really just the same thing. So we'll do equals area. And then so for our circumference, we'll just do diameter pi, which would be 44 pi. All right, now let's go ahead. I want you guys to try and do the next one. So we'll do this guy in red, all of his calculations. He has 16 spokes and he measures 59 inches from the ground. So let's draw this circle. I want you to go ahead and first calculate the area. If he measures 59 inches from the ground, that means that from here to here is 59 inches. All right. So go ahead. I want you to calculate the area. So to find the area of this, we first need to determine the diameter and the radius. So the diameter is going to be 59, and the radius is 59 divided by 2, right? So we end up with 29.5. So to find my area, I'm going to do radius squared times pi. So if I square that, I get 870.25 times pi. Or you could also, if you wanted to get, you could put that in a form of a mixed number, or I'm sorry, improper fraction if you wanted, but we'll leave it like this. And that's going to be inches squared. So now go ahead and try and find the circumference. So use the circumference formula. What would be the circumference? Ooh. So the circumference should be 59 pi. All right, and then I forgot units. It should just be inches because that's just length. All right, so now it says determine the central angle between the spokes on each wheel. So what are they talking about? Well, if you think about this guy up here, he has 12 spokes. All right, so I got to do that in blue. We're going back to the blue guy. So if he has 12 spokes, what that means is he's got, let's see if I can do this properly. Probably not, but we'll see. Because we need 6. we can cut this in half and then cut this into thirds. I know this isn't going to be perfect. These should be evenly spaced, but I'm not doing wonderfully, but I'm trying here. Let's see. So this should be 12, right? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, perfect. So let's imagine that I was really great at drawing this and these were all evenly spaced, right? So there are 12 angles here that are all equal. So to figure out the angle of between each spoke, well, we know that the entire thing is 360 degrees, so I just have to divide that by 12. So 360 divided by 12 gives me 30. All right, so my central angle between the spokes on the blue guy is going to be 30 degrees. So now go ahead. The red guy has 16 spokes. I'm not even going to bother drawing that. It honestly would just be a waste of everyone's time. But know that there are 16 different, it's split up into 16 angles. And of course, the full thing is 360. So how much would be the central angle between the spokes of the rear wheel? So in order to find that, you should do 360 divided by 16, which is going to give you 22.5 degrees as your central angle. All right, next it says find the distance on the circumference between two consecutive spokes for each wheel. Okay, so now let's take this guy as an example here. All right, they want us to find the distance of this. So it's actually not hard. We know that the distance all the way around, right, is going to be the circumference, because the circumference is the length all the way around. And the circumference for this guy was 44 pi, right? So to figure out what the distance from here to here is, we just need a portion of that. And what portion do we need of that? Well, it's 30 degrees out of the 360, right? So we only want a fraction. Well, what fraction is this? Now, there's a couple different ways you can set this up. We know that it's split up into 12, and we just want 1/12 of it, so you could multiply it by 1/12, all right? Another way to look at it, and you'll see that this actually reduces down, is this is 30 degrees out of 360. Now, you can use this fraction as well. There's going to be some times where you need to go to this, where you take the central angle and you put it over the total amount. Now, you'll notice, if you were to reduce this down, 30 divided by 360, it's going to give me 1/12, which is the same thing, which makes sense. So essentially what you end up doing is you have to multiply these. So you're going to go, actually I should have left the calculator up, sorry. So you're going to go in on your calculator and do 1/12 times 44, all right? So 1 divided by 12 times 44, and that's going to give us 11 pi over 3. All right, and that would be inches, because it's the length, all right? So now you're going to do the same thing for the other guy. All right, think about the fraction, and you're going to multiply, think about the fraction that each slices, and you're going to multiply that fraction by the diameter of the red guy, the rear wheel. So to find the circumference between the spokes, we know we split it up into 16, so we want 1/16 of the diameter, or the circumference, I apologize. And we know that that is 59 pi. So we're going to do 1/16 times 59, which is going to give me a gross fraction, 59 over 16 pi inches. All right. So that is how you essentially find arc length. Now, another way you could have done this, you would have gotten the same value as if you did 22.5 out of 360, because that's the central angle, and then multiplied that by your circumference. And we'll see if we get the same answer. 22.5 divided by 360 times 59 gives us the same answer. So that's another way you could have done it, and it's important to know both ways, right? You could do the central angle over 360, or you could just figure out what fraction of the circle that is. All right, so then for number 4, the wagons could cover a distance of 15 miles per day. How many more times would the wheel turn than how many more times would the front wheel turn than the back wheel? All right. So essentially what we need to do is we have to figure out how many inches are in 15 miles. So we can Google that. Oops. All right, so 15 miles is 950,400. Oops. All right. So if we wanted to convert miles to inches, we could use that conversion that I just looked up, right? 15 miles is equal to that many inches. Actually, sorry, this should be 15. All right. So I guess actually I had the internet convert it for us, because what happens is these cancel and you're left with 950,400 inches. Okay, so we know that these wheels need to travel that many inches. Okay, so to figure out how many times it's going to have to rotate completely, you're going to take the circumference and divide, right? Because, like, think about it this way. Like, if you had a circle, okay, and let's just say, like, it was, 3 inches all the way around. Well, as it rolls out, one rotation is going to be 3 inches across, right? So we're just going to take the distance for traveling and divide that by the circumference. So in this case, we're going to divide by 44 pi. All right, so we can do 950,400 divided by 44. Use parentheses. Pi. And at this point, I would say, let's see, how many more times? We'll round for this one. So we end up with, it's going to have to rotate about 6,875.4 times. All right. And then we can go ahead and figure that out for the other guy. So I want you to take the distance, which is 950,400 inches, and figure out, you're going to take the circumference and figure out how many times it's going to have to rotate. So to do that, you're going to divide by 59 pi. 590,400 divided by 59 pi. And you should get 5,127. We'll just round it to 5. So to figure out how many more times it's going to have to rotate, you would just subtract. So it's going to be about 1,748 more times. All right, so now we'll go ahead and do the set. Now, one thing I want to point out is previously when we did this problems, they wanted us to calculate theta. This time, all they want us to do is calculate cosine of theta, so that's different. If you want to calculate theta, that's the angle, so that's when you have to do like cos inverse, right, to find the angle measure. All they're asking for you is to figure out what cos of theta is equal to, and then you stop there. So it's actually not that bad. So you're finding like x over the radius. So let's go ahead and we'll do number 6. We'll go ahead and find the hypotenuse here. So we've got 4 and we've got 3 here, right? Because the 4 tells us to go 4 to the right, because that's our x value. The 3 tells us to go up. So to find the hypotenuse, we're going to do 3 squared plus 4 squared equals our radius squared. This gives us 9 and 16, which is going to give us 25, which gives us a radius of 5. So if I want to find cosine theta, all I have to do is my x value over my radius. And that's your answer. Cosine of theta equals 4/5. All right. They're not asking for theta. They're just asking for what cosine of theta is. If you wanted to find theta, you would have to plug in cosine inverse of 4/5. And that would give you the measure of this angle. All right. So now let's go ahead and try number 7. All right. So we've got that this is -4, and this is -4√3. So let's go ahead and find our hypotenuse. We have to do -4 squared plus -4 root. Oh, hold on. One of these is not, sorry, this one's not negative. So plus 4√3 squared equals your radius squared. Ah. Sorry. We get 16 plus, and just so you, I'm going to do this on here so you guys can see how you plug this into your calculator. So for, you would do 4√3, and then scroll over to close the parenthesis, and then you square that. All right, and that's going to give us 48. So you can add 16 to that. Oop. You get 64. So our radius equals 8. All right, so now looking at this, again, all you have to do is your x value over your hypotenuse. So what would be the value of sine? Now you're going to get a fraction. I want you to reduce the fraction. So cosine, oh, hold on. Actually, that was, scratch that. You're not finding sine. I apologize. They want you to find cosine, right? So figure out what cosine of theta is. Cosine of theta is x over your radius, right? So you have to take your x value, put it over your radius, and then reduce it. Tell me what you get. So it's going to be -4/8, which is going to give us -1/2. All right, so here cos of theta equals -1/2. Then here, we've got -√2/2, -√2/2. I want you guys to figure out what the hypotenuse is. So to find the hypotenuse, you have to go ahead and you're going to do -√2/2 squared plus -√2/2 squared equals your radius squared, right? That's your hypotenuse. So we do this, you should get 0.5 when we plug that into our calculator, which gives us 1. So we get our radius as 1. All right. So then when we do our cosine value, cosine of theta is going to equal our x value, which is -√2/2 all over 1. So you're just dividing it by 1, which means you end with what you started with. So cosine of theta should be -√2/2. All right. Then we've got this guy. So again, I want you to find the radius of this circle. What is the radius value? So to find the radius here, what you have to do is take our x value, which is 6√3, square it, and then do -6 squared. And 6√3 is going to give us 108. -6 squared is 36. Remember, whenever you square a negative number, it becomes positive. 108. It's going to give us 144. Which is going to give us a radius of 12. So to find cosine of this guy, we do our x value, which is 6/√3, And we're going to do that over 12. Well, we can simplify this radical. 6 over 12 gives us 1/2. So this goes to 1, this goes to 2. So you end up with root 3 on the top and a 2 on the bottom. So it's going to be root 3 over 2. All right. So it says, in each graph, the angle of rotation is indicated by the arc theta. Describe the angles of rotation that makes the x values of the point positive and the angles of rotation that make the x values negative. So what I want to point out here is, remember that this guy is 0, this guy is 90. This is always how it works. 0 starts here on the positive x-axis. The top of the y-axis is 90, this guy is 180, and this is 270, all right? So in between here, it's like 0 to 90. In between here, it's 90 to 180. In between here, it's 180 to 270, and in between here, it's 270 to 360, all right? So like if I said, you know, where would an angle of rotation of 200 be? What quadrant? Angle of rotation of 200 would be in this quadrant. Right? It'd be in quadrant 3. So you should be able to tell like which angles go in which quadrant. So anyhow, it says which ones give you positive points and negative points for cosine. So if you look, we got positive points, a positive cosine value, I should say, for 6 and for 9. So we got positive values between 0 and 90. And we got positive values from 270 to 360. Then if we look at our negative values, we got negative values from... We got a negative value here, which is in quadrant 3. And then we got a negative value here, which is in quadrant 2, right? So that's going to be from 90 to 270. It says, what do you notice about the x values and the value of cosine in the graph? So the x values... If we notice here, we have a positive x value, positive cosine value. Negative x value, negative cosine value. Negative x value, negative cosine value. Positive x value, positive cosine value. So they have the same sign. All right, let's see. So now it says, in the graph to the right, the radius of the circle is 1. The intersections of the circle and the axes are labeled. Based on your observation, what do you think the value of cosine might be for the following values of theta? So we know that we just kind of learned that the x values are associated with the cosine value, right? So at each of these degrees, we're going to want to look at the x value. So you've got 0, 90, 180, and 270. So at 90, your x value is 0. So your cosine value should be 0. And 180, your x value is -1. Your cosine value should be -1. Here, for 270, your x value is 0. For 360, your x value is 1. All right. So now for the go. This goes back to special right triangles. Okay? So we'll do a couple of these together, but you guys should kind of fish out. Remember those notes I gave you very specific instructions, like when given the side across from, 30, do this, blah, blah, blah. So I would try and find those notes. All right? That's what's going to help you here with the go. So if we look at 13, this is a special right triangle, and I'll tell you how I know it's a special right triangle. First off, they told us it's a right triangle. Okay, they said C is a right angle, so we can put that in there. And then they put these little notches here, which means it's isosceles. An isosceles right triangle is automatically a 45, 45, 90. All right, so if you recall a 45, 45, 90, it looks like this. You have your two sides, and then this side is x root 2. So, what do they want us to find the missing sides? Okay, so if these two are congruent, AC is going to be 5. And then AB is going to be 5 root 2. Okay? Because what you have to do when you're given a side is you have to multiply the side by root 2. So it becomes 5 root 2. Now if we go ahead, I'll do number 14. So first off, you guys should be able to tell me what would be the value of AC. So AC is going to be 7 root 2 because it's congruent to BC. Then to find AB, we know it's the side value times root 2. So I'm going to do 7 root 2 times root 2, which is going to give me 7 root 4, which is going to give me 7 times 2, which is 14. I guess I should probably put the units here because they had units. Sorry. Inches. All right. Now for 15 and 16, what we have to do is we end up having to divide, because basically they gave us the hypotenuse. And again, there's a 45, 45, 90 still. So the hypotenuse is your side value times root 2. So to get your side value, you have to divide by root 2. That's going to give you your x. Okay? So I'm going to do 13 root 2 over root 2. I end up with 13. All right, and again, I have to take my hypotenuse, divide by root 2. Now, I can't leave it like this because I got to rationalize. Remember doing that? So I would get 40 root 2 over root 4, which is equal to 40 root 2 over 2, which then is going to become 20 root 2 because the 40 and 2 cancel. And then BC is also 20 root 2. All right. So now we've got 30, 60, 90 triangles. Again, they told us that C is a 90. So you know that we're dealing with a 30, 60, 90 here. Okay? So if you recall a 30, 60, 90, let's see if I can draw this. We've got our 90 degrees, we've got our 30 degrees, and we've got our 60 degrees. And what we have to do here is this is the value of A, this is 2A, and then this would be A root 3. So again, you could use your notes to help you do this. So they gave us the hypotenuse here. So to find this value, you just have to take your hypotenuse and divide it by 2. So this guy is 7. Then, to find the side across from 60, you multiply the side across from 30 by root 3. All right. Then for 18, they gave us the side across from 30. So if you look at your notes, to find the side across from 90, you just multiply by 2. And to find the side across from 60, you multiply by root 3. So you'd end up with 25 root 3. And here for number 19, they gave us the side across from 60. So to find the side across from 30, you have to divide by root 3. It's going to give you 9. Then to find the side across from 90, you just multiply by 2. Multiply the side across from 30 by 2. I really hope you guys find your notes to help you with this. And here they gave you the side across from 60. So to find the side across from 30, I need to divide by root 3. So I'm going to do 12 divided by root 3. I got to rationalize, so I get 12 root 3 over root 9. 12 root 3 over 3, which is going to give me 4 root 3. Oops, I put my root. Then, the side across from 90 is 2 times the side across from 30. So that's just going to be 8 root 3. All right. And they want us to find AD in the figures below. So one thing, and I believe I kind of pointed this out to when we were learning about these triangles are basically the 30, 60, 90 comes from cutting an equilateral in half, which would be this. And the 45, 45, 90 comes from cutting a square in half diagonally. Okay, so we know we're dealing with a 30, 60, 90 here. Because this is an equilateral triangle, right? And if this is 60, this is 30, right? Because you cut it in half. This is 90, and then this is 60. Because in an equilateral triangle, all the angles are equal to 60 degrees. So anyhow, they want us to find AD. So we can find our side across from 30 by taking the side across from 90 and dividing by 2. We can find the side across from 60 by taking the side across from 30 and multiplying by root 3. So it is actually 8 root 3. All right. Then we've got 22 here. So they gave us the, well, actually, let me show you this. So we know this is 90 degrees. So one of the properties of a square is that the diagonals bisect the angles. So that means that this is 45, this is 45. So we've got a 45, 45, 90. That's where the 45, 45, 90 is derived from. So they give us the hypotenuse, which is 11. So to find the sides, you have to divide by root 2. So you should get 11 root 2 over 2. Sorry, the answer key was wrong and it threw me off there. Oh wait, hold on, what? Interesting, okay. But yeah, this is correct. So you would take that and divide by root 2. The publishers made an error. All right. So then let's go ahead and finish this up. So we've got, if you purchased pi gallons of gasoline, how many gallons of gasoline did you buy? Okay, well, what is pi equal to? You can even just go on your calculator and it should give you like a decimal equivalent to pi. So let's do that. Pi is, right, we know pi goes on forever. So we can't get an exact estimate of pi because there is no, like, you can't get an exact value for pi because it goes on forever. But we could say, well, you would have approximately 3.14 gallons of gas, right? All right. If you were paid 5 pi dollars per hour, about how many dollars would you make in 8 hours? Okay. So you're paid 5 pi per hour. So we could figure out about how much you're paid per hour, right? That'd be 5 times pi. That's 15.71. So we'll say about $15.71 per hour. And they want to know how much we're going to make in 8 hours. So you would just multiply that by 8. And you get 125.66. All right. And then they said if you slept 2 pi hours each night, how many hours of sleep would you get per night? So you get 2 pi hours of sleep. That would be 2 times pi gives me 6.28 hours.